Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, let's have a look at some equations and balancing chemical equations. So, what do we add when we are trying to balance equations? Those are our stoichiometric coefficients, those large numbers that we put in front of either our products or our reactants in the equation. And what can't we change? We cannot change the formula itself of the reactants or of the products. So all we can do is put the big numbers in front of them to try and balance our left-hand side and our right-hand side of the equation. Okay, so let's give this a go then. We need to create a balanced symbol equation, including state symbols for the following reaction. And that reaction is iron 3 oxide reacts with graphite to form iron and carbon dioxide. Okay, so let's look at that first part, our iron 3 oxide first. So that is going to be an ionic compound because I've got a metal reacting with a non-metal. So let's write the formula for that first. We've got iron 3. Remember that 3 in Roman numerals means that the charge on this iron ion is +3. And then oxide comes from oxygen, and remember oxygen is in group 6, so it needs 2 electrons to fill its outer shell, and that's why my oxide ions have a charge of -2. So at the minute those two are not balanced. I have got too many positive charges, 3, and too few negative charges, -2. So let me add another oxide ion. If I add that, I now have 3 positive charges and 4 negative charges. So okay, I need some more positive ones now. So let me add another ion. Sorry, not ion, iron. Now I've got 6 positive charges and 4 negative charges, another oxide ion, and finally I am balanced there. So my formula for iron 3 oxide is Fe2O3. And I've been asked as well for the state symbols in this particular question. Since it is ionic, what we know is they're going to be a high melting point. So this iron oxide is a solid. Okay, let's look at the rest of the equation then. So we have that it reacts with graphite. So that is my carbon, C, and S for solid form to form iron. That's Fe, the symbol, and then S again. So that is a giant metallic bonding for iron, high melting point, and iron is a solid. And carbon dioxide. And we know carbon dioxide is a gas, simple covalent, so it has a low boiling point. And remember that dioxide means 2 of my oxygen atoms. Okay, so what I have got here now is an unbalanced equation. So I need to balance it. So let's get my table and let's count everything up. So on my left-hand side, I have 2 iron. On my right-hand side, I have 1. On my left-hand side, I have 1 carbon. And on my right-hand side, I have 1. And on my left-hand side, I have 3 oxygen. And on my right-hand side, I have 2. So things are not quite balanced yet. The first thing I'm going to try and balance are those oxygens. So remember this idea that 3 times 2 is the same as 2 times 3. So what I'm going to do is I'm going to put a 2 in front of that iron oxide, and I'm going to put a 3 in front of that carbon dioxide. Because by doing that, on my left-hand side now, 2 times those 3 oxygen of iron oxide gives me 6 oxygen on my left-hand side. And on my right, 3 times those 2 oxygens from the carbon dioxide gives me 6 oxygen on the right-hand side as well. Okay, but by doing that, I have affected some other things as well in my equation. So now, if I look at my left-hand side, yes, I've got 6 oxygen, but also I've multiplied those 2 ions by 2. So I've now got 4 iron on my left-hand side and still only 1 ion on my right-hand side. And the other thing I've done by putting a 3 in front of that carbon dioxide is I've now got 3 carbon on my right-hand side of the equation. Okay, so it's unbalanced, so let's fix that. So what I'm going to do is I am going to put a 4 in front of my iron on the right hand side, and now that matches the amount of iron on my left hand side, and I'm going to put a 3 in front of my graphite on the left hand side, so I've got 3 carbon there, and then I've got 3 on my right hand side as well. So now that is all balanced. Okay, let's look at another example. Create a balanced symbol equation, including state symbols for the following reaction. So this time we've got sodium carbonate powder is added to a solution of hydrochloric acid. They react to form carbon dioxide, sodium chloride, and water. Okay, let's deal with the sodium carbonate first. And remember, you need to know carbonate as one of your complex ions that you need to learn the structure of. So you've got CO3, and that has got a -2 charge. And then my sodium here, I've got a +1 charge. That is because sodium is in group 1, so it will lose one of its electrons to have a full outer shell. So let's have a look then. I haven't got balanced charges here. I have got 2 negative charges, 1 positive charge. So I need more positive charges. So let me add another sodium. Good, now I've got +2 on the left, -2 on the right. I can write my formula for sodium carbonate as Na2CO3. Okay, next part here is to appreciate it was a powder. So that tells me that it is a solid. So that's my state symbol S here. Add hydrochloric acid, HCl, and I get sodium chloride. So again, what I've had to do here is think about the ionic bonding. So think about the fact that chlorine is in group 7 and therefore needs to gain 1 electron, and sodium is in group 1 and needs to lose 1 electron to have a full outer shell. Those charges are balanced. So that one was quite simple. So NaCl. And then I also get carbon dioxide and water, H2O. Okay, and some help with these state symbols. So it's a solution of hydrochloric acid, so it's aqueous. And my sodium chloride that I've got is ionic, so you assume that it is soluble in water, and therefore in this equation it's aqueous. And then we know carbon dioxide is a gas, and H2O, water, is a liquid. So let's have a look at my table before I attempt to balance this unbalanced equation then. So on the left here, I have got 2 sodium, and on the right, I have got 1. On the left, I have got 1 carbon here, and on the right, I have got 1 carbon as well. On the left, I've got 3 oxygen coming from that O3. On the right here, I've got 2 oxygen coming from that CO2, and I've got another oxygen coming from H2O. So I've got 3 oxygen on both sides. Then let me have a little look at my hydrogen. So on the left, I've got 1 in my hydrochloric acid, and on the right, I've got 2 in my H2O. And chlorine, on the left, I've got 1. On the right, I have also got 1. Okay, so let's try and make these balanced. Let's start with my sodium, okay, because at the minute I've got 2 on the left and only 1 on the right. So let me put a 2 in front of my sodium chloride, and that has now given me 2 on both sides, so sodium left and right, but it has also changed my chlorine on my right-hand side, instead of just being 1 to be 2. So I need to scribble that out and write 2 there as well. Okay, so that's no good because now I've unbalanced my chlorine. So now I need my left-hand side to have more chlorine. So all I can do is put a 2 in front of my hydrochloric acid, HCl, and let's see what that's done. Okay, it's balanced my chlorine, and the other effect that this has had here is that that's changed my hydrogen on my left-hand side from 1 to 2. That's good because now they balance, because my left-hand side now has 2 and my right-hand side of the equation in H2O has 2 hydrogen. So there we are, I'm done. That's my fully balanced equation.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, time for some tips and tricks for this section. So whilst it's good to show this table and get to grips with all of your balancing, eventually you probably won't actually need to use the table in order to do it. However, that being said, it is a great tool for checking your work. So if you have time in your exam and you've done it without the table, you can go back and try it with the table to double check that you've balanced it correctly. Remember this trick about multiplying. It doesn't matter if you multiply 2 by 3 or 3 by 2, that both gives you 6, okay, with that example when we had my oxygens. If things don't seem to be working out, try doubling everything and then have another look at what you've got. So that's just an extra little tip. But usually you do have to mess around with these a little bit before they balance. They might not balance exactly correctly first time. So just be aware you might even have to do that.